All right, so the first example we're going to do today, the first example we're going to do is from the worksheet number 1A. It's a very straightforward example, looks like that. So it's very similar to the construct understanding. Step 1 is to isolate the trig function. So we want to solve that so it says sine x equals. So what is that going to look like then? Alex, if we rearrange this to say sine x equals, what will it look like?
Sine x equals -1/2.
Good. Okay. And on this sheet it says we're going from 0 to 2 pi. Okay. So and also on the sheet it says we want exact values. So recognize that that is one of your special ratios. And you've already seen this question, right? It was the get started question. But in the get started it was degrees and we want it in radians. So the first thing to ask yourself is, sine of what angle is positive a half? So ignore the negative for now. The reference angle is the angle that if I take the sine of it, I get positive a half. And what is that?
30.
In radians?
0.5.
In radians. In terms of pi, exact values, no decimals. Pi over 6. Okay? So pi over 6 is your reference angle in radians in terms of pi. Now we ask ourselves, what quadrants do we want to be in? 3 and 4, because that's where sine is negative, and we have sine equal to a negative value. So my reference angle is pi by 6 here and here. So I need to know what is that value and also what is that value if I'm going from 0 to 2 pi. So the first one is if I add pi by 6 to pi. Now think about pi here and 2 pi here. Pi is the same as 6 pi by 6. And 2 pi is 12 pi by 6. So what's my very first angle? 7 pi by 6, because it's 6 pi by 6 plus another pi by 6 is 7 pi by 6. And what about the second angle in the fourth quadrant? It's 12 pi by 6, back it up a pi by 6. So 11 pi by 6. So that's my solution between 0 and 2 pi. Notice that I have two solutions because I'm going to have one period from 0 to 2 pi. The general solution I take all the solutions on the first period, which is 7 pi by 6 and 11 pi by 6. And what do I add to those? Multiples of 2 pi, where n is an integer. And that's the general solution. Questions about that? And you need to get used to that. So when we have a squared function, so this is just like writing it like this. That's what that means, okay? Sine 3x all squared equals 1. So M is absolutely right. We got to take the square root of that to get the squared out of there. So what will sine 3x be equal to? Or? Yeah, plus or minus 1. Okay? Plus or minus 1 because of the square. So because of when we have a degree 2 function like this, quite often we will have two solutions, and that's what we have. Plus or minus 1. So if you think about how this graphs, sine x looks like this from 0 to 2 pi. So let's ignore the 3x just for a moment and pretend this is just sine A equals plus or minus 1. So we're going to ignore the 3x. Sine A equals positive 1 up here, and it equals negative 1 down here. What are those x values? What's that x value? pi by 2. And what's this x value right here? 3 pi by 2. Okay? But we don't have sine A, we have sine 3x. What does the 3, and those are the two solutions on the first period. What does the 3 do to this function? Changes the period because it compresses it by how much? A third. So if it compresses it by a third, then before, if one period fit from 0 to 2 pi, now how many periods are going to fit from 0 to 2 pi? How many? 6. Not 6. So this is what it was shaped like, and we want to compress it by a third. So the whole thing fit 0 to 2 pi. Now a third of it is in there. So how many more can I have? 2 more. So I've got 2 more on that period and 2 more solutions on that period. So I'm going to have 6 solutions altogether, Matthew. So maybe that's what you meant. Okay? But also these zeros are going to compress. So before it was pi by 2, we need to compress that by a third and get pi by 6. And 3 pi by 2 is going to become 3 pi by 6, which of course is pi by 2. But I'm going to just leave it that way for a moment. Okay? How do I find the next one right here? What will I do? Pi by 6 plus the period. Yes. And what is the period? Dylan, what's the period for this function here? Normally, this function had a period of? Sine A has a period of?
Yeah. Oh, it would be 2 pi.
2 pi. But this compresses it by a third, so the new period is?
Would it just be 2 pi over 3?
Yeah. So I'm going to rewrite that as 4 pi over 6 so it's easier to add. So I'm going to take pi by 6 and add 4 pi by 6. And what do I get? 5 pi by 6. Now I'm going to add 4 pi by 6 to this and get 7 pi by 6. Then I'm going to add 4 pi by 6 to this and get 9 pi by 6. And I'm going to add 4 pi by 6 to this and get 11 pi by 6. So those are my 6 solutions that go from 0 to 2 pi. Okay? Now these ones I would reduce. That's pi by 2. And this one is 3 pi by 2. Okay, just to simplify those fractions. But those are the 6 solutions that I would have. Okay? 6 solutions because the plus 1 created 3 of them, and the minus 1 created 3 of them. What if I wanted to write the general solution? Which of these values would I need? I just need the ones on the very first period, so pi by 6 and pi by 2. And I need to add what? What am I going to add to them, Charlotte?
You add
2 pi by 3 n. So the period multiplied by n, where n is an integer. Okay, next example. I'm going to do this one. I'm not going to do this period change question. We just did a period change question. Okay? So this bit in the box here is just a little reminder. But the question we're going to look at is, can you throw that in the recycle, please, Emma? Thanks. I know you didn't make it. Just throw it in the recycle and then it's taken care of. So we have cos x plus cos x tan x equals 0. Okay? So what I am reminding you of over here is that tan x is the same as sine x over cos x. And that's important because tan x has something in the denominator. And if it has something in the denominator, what does that introduce into my equation? What can we never have in the denominator? We can never have 0 in the denominator. That's a non-permissible value. So if I have a situation, an equation that has tan x in it, I need to recognize the non-permissible values. And the non-permissible values are anywhere that cos x equals 0. And where does cos x equal 0? So look on the other side of your sheet and tell me, where does cos x equal 0? Pi over 2 and 3 pi by 2, etc., right? So those are where the asymptotes are for tan, right? Those are the non-permissible values. Okay, so I'm pointing that out now. So we're thinking about non-permissible values anytime I have tan or cotan or cosecant or secant in an equation, because they all have denominators. Cosine and sine don't have denominators. Okay? Now how am I going to solve this? I need to isolate the trig functions so that it says cos x equals tan x equals. How do I do that with this function? Or with this equation, pardon me. Any suggestions about what I can do? Good. So we have this situation here. So we're going to factor out the cos so that it says cos x. When I factor out the cos, I'm going to have 1 plus tan x. Okay? And why that works is because now that it's in factored form, if I have 2 or more factors that multiply to give me 0, then either this factor has to equal 0 or this factor has to equal 0, which looks like that. Now, what do you notice right away? Pardon me, Shayna? Right, cos x equals 0, so that's a non-permissible value. So that's not one of my solutions. And that's why it's a good idea to think about those ahead of time. Otherwise, you go to a whole lot of work and you get the answer wrong, which would be terrible. But we do know where tan x equals -1. Where does tan x equal -1? Not pi by 4, 3 pi by 4, and 7 pi by 4. Okay? So what about the general solution? What about the general solution? How would I write it? How many solutions do I have on the first period of tan? Just the one, just the 3 pi by 4. Because remember that the way we got the 7 pi by 4 is we added pi to it. So those are already a period apart. I only need the very first period solution, which is that one. Plus, what am I going to add to it? Not 2 pi this time, but pi n. Why just pi n? Period of tan is pi. We're going to do that one right there. Okay, 2 cos squared x plus cos x minus 1 equals 0. And we need to have statements that say cos x equals. How do I do that? When you look at that for very long, what do you notice about it? Matthew?
It's, what do they call it? The 1-3 split quadratic.
It's a quadratic. Okay? So if you notice here, the cos x, if we just think of that as some variable a, we have 2a squared plus a minus 1. Can you factor 2a squared plus a minus 1? The answer to that question should be yes, because it is factorable. So let's factor 2a squared plus a minus 1 equals 0. See what you get. Remember, you want two numbers that multiply to -2 and add to 1. 2 and -1. Questions about that? So your job in the time that is left is to try some of these from the worksheet or from the textbook. And you should be able to do all of them by Monday. Or be able to get help with the ones that you're having difficulty with. Yes, Dylan. My expectation is that you're going to use the next 17 minutes to do that. Yeah. Okay, I can't give you permission to leave, but you have to go to the office, okay, and sign out? Yeah. Yeah.